This problem has two parts, or two configurations for three particles fixed on the x-axis. Here particles B and C are pushing particle A away from them since the charges are all positive. The net electrostatic force on particle A due to particles B and C is in the opposite direction relative to the unit vector x. The absolute value of the electrostatic force is given in the text. Let's call it Fa. Now let's apply Coulomb's law to each force. And here we use the principle of superposition to add the two forces and get the net force on particle A. I am also factoring out the minus sign. The absolute value of the net force must be equal to Fa. So we can write an equation relating these quantities. Let's also factor out other common terms. Or we could change it a little in order to substitute it for x squared in part B of the problem. We deal with situation B now. Particle B is now fixed on the left of particle A. The absolute value of the distance it is from A is the same as before. This change of position implies that the force on particle A due to B is now in the direction of the unit vector x. So it will be positive. But the force on A due to C is the same as in the first configuration. And as such, it is negative. Again, the absolute value of the net force is given. Let's call this value Fb for now. No complications here, we just repeat what we did before. Apply Coulomb's law and the principle of superposition. We also write another equation with the component of the net force and its absolute value. Let's also factor out common terms. Now we substitute x squared in this equation with what we solved for in the first part of the problem. This is getting ugly. Sorry. Let's simplify things a bit. Let's call the ratio on the right side v, so we can simplify even more. Here we divide both sides of the equation by QB. See? It is starting to look like we may get to the answer. Now we factor out the quotient QC over QB. And there it is, folks, the answer. If you go back and see what is the value of V, you will get the final value we show here.